Hi, and welcome to episode number 28 of the weekly Google Cloud Platform podcast. I am Francesc and Mark, and I'm here with my colleague Mark Mandel. Hey, Mark.
Hey, Francesc. How you doing today?
Very good, very good. Very interested with the main content of the week.
Yeah, we're moving away from some of the shiny things, sort of stepping away from containers, stepping away from App Engine, going like, let's just talk about VMs.
Yeah, what is a virtual machine? How do you use them at Google? How are better ours than others, etc. I think it's going to be very interesting. We're going to have... what's his name?
Scott Van Woudenberg will be joining us.
Scott Van Woudenberg, yes. And a very good pronunciation of that one, by the way.
Thank you. I've been working on my pronunciation of names.
Yeah. So yeah, we're gonna have him, and then afterwards we're gonna have a question of the week that comes from one of our listeners, Noam Franco.
He's looking at how we can connect data store backups to BigQuery.
Yeah, exactly. So yeah, we're gonna end up doing that question of the week at the end of the episode. But before, we have the cool thing of the week.
Yeah, we have this really great new Udacity course from two of our team members, Kelsey Hightower and Carter Morgan, who have done a Kubernetes online Udacity course.
Yep. And it is pretty amazing just because seeing those two people working together is already amazing. Yeah. They're really, really fun. But also basically it's going to take you from the basics to what is a container and how do you use them to create microservices, to then create Kubernetes clusters and then deploy microservices on them, and basically everything from scratch to having your own microservices running on the cloud.
Yeah, and best of all, it's free.
Oh yeah, absolutely. It's absolutely free, which is awesome. And you can find a link on our show notes.
Yeah. It should be very interesting to get done.
Yeah, I'm definitely going to go through it. I'm pretty sure I know most of it. I'm sure I will learn some new stuff.
Yep.
But I think it's just going to be fun to see them presenting.
Yeah, that sounds really, really good.
Cool. So what do you think? Should we go talk to Scott?
That sounds like a great idea. Let's talk about virtual machines. We are joined today by Scott Van Woudenberg, PM on Compute Engine. Scott, how are you doing today?
Good, doing well. Thanks, guys. Thanks for having me on.
Absolutely. Before we get stuck into what you do at Google and like the products you work on, why don't you tell us a little bit about yourself and your role and all that sort of fun stuff?
Sure. So I'm a product manager on Google Compute Engine, which is our infrastructure as a service offering, which is part of our broader Google Cloud Platform. Before Google, I was spent about 16 years as a software engineer and engineering lead and manager, kind of moving up the chain on the engineering side of the house before I decided to switch to product management. So I came to Google in 2012 to be a PM on Compute Engine, and I've been doing it ever since. Right around the time I joined, basically a few weeks after I joined, GCE was announced publicly for the first time. We kind of announced we called it limited preview at the time, but it's basically our alpha launch at that year's Google I/O. So it's been a very exciting ride to ride the exponential growth curve that we've seen since we started, and especially since we GA'd back in 2013.
Excellent. All right. Wonderful. Well, thanks so much for joining us. Well, let's sort of start at the most basic level that we can. What is a virtual machine? Like, I'm sure a lot of our listeners probably have a bit of an idea, but I think let's sort of go as simple as possible. What is it?
Yeah. So this is actually. This is kind of a tough question to answer tersely, I guess, or succinctly. I spent a little time kind of researching and took a look at what Wikipedia had to say about it, and kind of the most basic definition I could find was essentially a virtual machine is a software implementation of a physical computer or server. So, and then obviously on Wikipedia it was followed by a few pages of like fairly low level technical detail on virtualization, on hypervisors, on paravirtualized devices, on yada. The list goes on and on. And then along with about 24 reference links down at the bottom where you could go read about more detail. So I kind of stepped back and thought about it. And I think, for the purposes of this discussion and just kind of for cloud customers that are looking at GCE or comparing it against EC2, or just trying to understand, maybe you come from an app engine background, or you're a front end developer, or, for depending on where you're coming from, it's best just to kind of think of a VM as a trusted, ubiquitous computing environment that lets you decouple the actual code that runs from the hardware that it runs on. So think of it as an abstraction layer that is both secure and ubiquitous, which are kind of the two things that have made virtual machines, as popular as they are.
So, like containers?
So containers is actually that is a excellent example of a computing abstraction that is not yet very secure. And it is also not yet quite as ubiquitous as virtual machines. There will be a day sometime down the road where all of the security issues get worked out. Like, you can have complete isolation between two containers running on the same host, and there'll be a very secure, trusted sandbox is kind of how we think about these environments. Computing abstraction layers run in these sandboxes, kind of like a JVM, kind of like like any interpreted language has like a runtime environment. That runtime environment, that sandbox, has to be proven to be secure, and it's impossible for one container to break out of that sandbox environment to muck with the memory or other area, a different containers environment, so that you can have a true multi-tenant computing platform, which is really what VMs gives you. And the reason why VMs is where it is because VMware started this whole game 12 years ago, and has basically taken the market by storm. Back in the day, before VMware, everything ran just on directly on hardware, and VMware added this virtualization abstraction, and it really took off. But it's been secure. They've been finding all the bugs and making sure that it's secure for the last 10, 12 years. So containers is just kind of at the beginning of that curve, I think.
So, and other than for security concerns that you were mentioning, why would someone choose running a VM using Google Compute Engine rather than App Engine or Kubernetes or Container Engine?
Yeah, so the simplest answer is because that's what, like, enterprises, anybody coming to the cloud that has existing workloads either on-prem or on AWS or elsewhere, it's going to be like a compute engine or, infrastructure as a service is going to be the most familiar and, probably most like what they're currently running, especially enterprises where most of them are running on in their data centers or in colo environments or whatever. They're probably using VMware. The majority of them are using VMware, running virtual machines. It's what they're familiar with. This is basically infrastructure is going to be most customers' on-ramp into the cloud. And then once they're on the cloud and they're out of the business of managing their own data centers, like doing their 3 or 5 year hardware refreshes and dealing with all of that stuff. Once they've moved those applications to the cloud onto GCE, from there they'll then be able to start decomposing, rewriting components, kind of splitting them out into microservices and taking advantage of some of the other really cool technologies that Cloud Platform offers. And not our Cloud Platform obviously offers some really amazing, especially big data analytics, machine learning. We've got a ton of really amazing products that abstract that are built at a higher level of abstraction. Like the machine learning is basically an open source API, so you don't actually have to manage underlying resources if you don't want to. And Kubernetes is a great example of that, where you just write your code and write your containers, like what you want to implement in a container, deploy it as a microservice, and deploy dozens of other ones, and they all start talking to each other. That's really kind of the power there. You don't have to think about like the hardware, how much RAM, how many cores, like am I using it efficiently, all that other stuff. You just stop thinking about it, and that's the advantage of moving up the stack. But as far as getting workloads into cloud, the first step, the on-ramp, is going to be GCE.
Apart from that sort of general on-ramp to come into the cloud, are there any particular use cases you see that people are like, oh, VMs are just much better for this than say, maybe some of the more shiny technologies out there?
So I think, it really kind of depends on what people like to focus on. Like, at the end of the day, virtual machines give you absolute control over every layer, every piece of the software you control. You are the one that writes all the code to do like auto scaling up and and down, and basically scaling the number of VMs that you have based on the incoming demand and requests per second, whatever the metric is. So really, for the very sophisticated customers or applications that need control over every aspect of their application, virtual machines is probably going to continue to be the go-to product or go-to technology for some of those. There's also stuff like, if you have to run something like SQL Server or something like a third-party software package that doesn't really have like a containerized version, it's not available like to an App Engine app, like a video encoding library, for example. Like we have tons of App Engine customers that basically use App Engine to orchestrate, to do the front end serving, but then also to orchestrate like kind of transcoding workloads like media rendering, that sort of thing. And that's where they basically break out of the App Engine layer, use GAE, App Engine Flex to run GCE VMs, but still managed by App Engine. And those VMs, the only thing that they're doing is pulling, videos or audio off of SQ and transcoding it, because you can actually run libmmpeg and the other transcoding libraries, which are typically written in C. You can just run those in a VM, where you can't really run those in App Engine without rewriting them as a Python library or something like that, which is just too much work.
I think you just went exactly through the architecture of the of CloudSpin. I presented at Google I/O. It was exactly that.
Yep. It's a very popular model, and App Engine makes it really. App Engine plus GA App Engine Flex make it really easy to manage the VMs. You still. You know that they're there, but it handles all of the orchestration, and so you don't have to, and it just makes it super simple.
So I have one more question regarding this trend towards containers. So you said that for VMs, it's like a very good place to, when you're doing my favorite phrase, lift and shift, to get started on the cloud. Then some people move to containers. And what is your opinion on this trend towards serverless computing, taking into account that all your business is selling servers?
So serverless is, there's a couple interpretations. So like one interpretation of what that means is I just write code. I don't have to think about like the underlying deployment orchestration. I don't have to think about, how that code gets scaled up and scaled down to handle increased load, like the diurnal cycles, that sort of thing. So, it basically just means that the product or whatever it is that I'm programming against has abstracted away the fact that under the covers there's servers that are connected over networks and stuff like that. So that's kind of one interpretation. Another one is just, look, I just have like kind of like the Cloud Functions model or the AWS Lambda model, where you're just writing like these little snippets of code that you need to run as when some trigger comes in. I don't know, like I've just pushed a new request onto like an entry onto a task queue. I want that to trigger a Cloud Function to run and pull that off the task queue and do something to it, and then push it back onto a different task queue or something. And that's really where something like Cloud Functions, you really aren't even you're worried about even less. You just write a function, essentially what ends up being like a function in whatever your favorite language is, and then that you hook it up. You set up a trigger, and then that function goes off and does something, which may trigger other functions to run, which gives you this ability to kind of just write individual functions, hook them all together, and you end up building like these kind of crazy complicated applications that never have to touch, never have to even think about like the notion of even a container. Like it's completely abstracted away even beyond that.
Cool. So since we're talking about compute engine, and you are pretty much the expert on the topic, what are your favorite features of GC?
So I think like a lot of my favorite features come from like kind of the underlying flexible infrastructure that we're built on. So like two of the best examples and my personal favorites are the per minute billing that we have, and then the automatic sustained use discounts. So per minute billing, most of the big hyperscale cloud offerings right now bill per hour. So if you spin up a virtual machine, you run it for like 20 minutes, and then you shut it down, you get charged for an entire hour. For Compute Engine, you only get charged for those 20 minutes. And then if you start it up again and run it for, another 15 minutes, then you only get charged for those 15 minutes instead of it being rounded up to an hour. Now, we do have a 10-minute minimum. So if you spin it up for 3 minutes, you get charged for 10 minutes. But really, it's pretty significant savings if what you're doing with the VM doesn't typically take, on the order of multiple hours. And obviously the longer the VM runs, the less of impact or less of a savings you get. But that's where sustained use discounts comes in, which is the longer you run the VM for a given month, the cheaper that VM, the per hour or per minute cost of that VM is. So if you run a VM 24/7 for an entire month, you basically get like 30% discount off of the list price for that entire month. And we just kind of, at the end of the month, we aggregate all of your VMs up and do the math to basically give you a discount over all of the usage based on how long those VMs ran for that month. And that's all, especially the permanent billing. That's really kind of comes down to like some of the flexible real-time data processing infrastructure that we have here at Google that lets us do, almost near real-time billing and monetization like that, which is when you're talking about, the number of VMs that GCE runs on behalf of their customers, like doing per minute billing for all of those VMs all the time is actually a pretty significant data processing challenge. But that's the type of thing that Google's good at. And so we've leveraged some of that in-house expertise to solve it. Another of my favorite features is custom machine types. That's basically when you go to create a VM, you typically specify what's called an instance type or a machine type, and that basically is kind of the hardware spec, like the virtual hardware spec of the VM. So it's the number of cores you want, how much RAM you want, and basically what GCE offers that none of the major competitors offer is the ability to customize that. Like, I don't need a 8 cores, but 4 cores is too small. So I'm going to create a 6-core VM, and I happen to know that I need 2 gigs per core. So I'm going to create a 6-core, 12 gigabyte of RAM virtual machine using custom machine types. And that lets me save money over the next highest up. So actually, let me take a quick step back. We also, like GCE as well as the other major public clouds, give you a selection of predefined instance types or machine types. So, Google calls them like N1 standard 1, N1 high mem 4, et cetera. And the standard high mem high CPU really just refers to the RAM to core ratio. Competitors offer, like AWS offers the C3 4x large, C4 2x large, et cetera, et cetera. So there's these predefined machine types that you get or that you have to choose from. But if your workload doesn't fit exactly into, like, it's too small for like a C4 2x large, but too small for a C4x large, or too big for a C4x large, you basically have to buy the next size up, or you have to figure out how to tailor your workload so that it fits exactly into one of those predefined shapes. And that's where custom machine types really shines, is the ability to tailor the VM shape to the workload, not vice versa. And that's especially important for enterprises coming to the cloud, because what they're probably running on is like a Dell server that's got some number of cores and some amount of RAM, and that's basically their homogeneous fleet that they're running right now for all these different applications. And instead of having to kind of scratch their heads and figure out how to adjust the workload so that it fits in with one of these predefined types, they just go create a custom machine type that exactly mimics what they have on-prem, and they're off to the races. It's one less kind of pain point or friction point in moving to GCE from an existing on-prem environment.
And that would seem to me as well like a really nice cost savings as well. I know I do some stuff with gaming companies, and so often they want like necessarily a whole lot of RAM, but they don't necessarily need like the fastest CPU in the world. So when you're in that sort of cookie cutter world and you have to have both of those at the same time, this is a nice way to say, hey, no, we don't need that much CPU. That's fine, but lots of RAM, so we can really spend our money exactly where we need it.
Yes, exactly.
Yeah, there's one of the things you've been talking a lot about, the flexibility of our infrastructure. And one of the places where I think it shows is the fact that we're able to resize persistent disks while the instance is running and the disk is attached to it.
Yep.
that is something that first time I showed to a customer, they were just impressed with that. It was like, oh, how is this magic? How does that work?
Yeah, that's funny. That was something that we launched fairly recently, and I don't think it's really kind of hit the kind of customer psyche or whatever you want, kind of collective customer psyche, because it is a super powerful feature. And the customers that have encountered, there's a lot of issues that happen that could cause your, especially your root boot partition to fill up. Like your boot PD, typically we only allocate 10 gigs worth or 20 gigs worth. You keep those small because you don't put any data on them and stuff like that. But still, most guest OS dump all of their logging information on there, et cetera. And so if for whatever reason you're not paying attention and you don't have any alerts set up and the root volume fills up with log data or something, then all of a sudden you're now no longer able to SSH into your VM because SSH relies on being able to write its own logs, and when that fails, everything fails basically. And this is common, not just on, this is basically any Linux, any server that runs. If you fill up the root partition, bad things happen. And this hot resize is just a super easy and quick way to be like, oh crap, I had a runaway log script or something, and my volume's filled up. Let me just go into the UI, click 2 buttons, and double the size of the root PD volume, so I can go in and fix my spammy log file or fix whatever it is that's filling up the root partition. It's such a convenient and powerful mechanism, and it's not just related to root volumes. Obviously, if you've got data volumes that, let's say you use GCS connector to pull a bunch of data from GCS to a local VM to run to a bunch of VMs PDs to do a Hadoop job, and you're writing out the results, and all of a sudden the job fails because the data disk that you were writing out to is full. You know what? You just go resize the disk and rerun the job, and all of a sudden you're good to go. You don't have to stop the VM. You don't have to shut everything down and detach it and resize it or create a bigger one and copy everything. It's just super, super powerful.
Yeah, you could even consider doing that through the API, so you don't need to even just click a single button. Just everything happens. Yeah, which is amazing.
Set up a stack driver alert that triggers a stack driver alert that when it gets 90% full, call a cloud function that calls the GCE API that resizes the disk up, doubles the size of the disk.
So many cloud things in that sentence.
I'm pretty sure our teammate Terry has a little script that he demoed showing off doing exactly that, where it keeps track of how much data you've got and how much free space you have, and then if it runs out, it's I'm just going to double your partition here. Yep. It'll be fine.
But you might want to look at this at some point to figure out why it's filling up. But in the meantime, just go fix it.
Yeah.
No, that's really cool, and I think that touches on some other stuff too. For example, we can do a bunch of stuff to your infrastructure as it's running. You want to talk a little bit about live migrations and how that works?
Yeah, sure. So, one of the biggest challenges for a cloud provider is keeping the software and hardware infrastructure that all the VMs run on, keeping it up to date, keeping it patched, secure, rolling out new versions of all the different layers of that stack, et cetera. And, if it's something significant like upgrading the host kernel that is running on the server that your VMs are running on, obviously that's a very, disruptive action for VMs or anything that's running on that host. You basically have to take everything off the host, what we call drain. We have to drain the host and do the upgrade and then reboot it, and it comes up on the new kernel. That's all and so within that reality and the reality of maintaining these systems and keeping them all up to date and patched, what we've done for GCE is built this technology called live migration. This is not we didn't invent the technology. VMware has been doing, their own version of live migration. They call it vMotion for many years. But we're the first public cloud hyperscale provider to do live migration at the scale that we're doing live migration. Obviously we run lots and lots of VMs across many, many zones, and we use live migration quite a bit to make sure that all of our underlying systems are patched and updated and all without disrupting the VM. So what a live migration does is it basically, your VM is running on one host machine, and let's say we got to take that host machine offline to do a host kernel kernel upgrades. So what we do is we, trigger live migrations for the VMs that are running on that host machine. And what a live migration does is while the VM is running, it starts copying the state over. It creates a new virtual machine target on a different host, starts copying all of the state, like RAM, the VM, the specification for the VM, the machine type, all of the different PDs and things like that, network connections, basically creates an exact mirror of that virtual machine on a different host. And then once we've copied the majority of the state, we pause the source VM briefly, and then unpause it, copy the rest of the remaining state, and then unpause it on the target. And now that VM is now running on a different host machine without any impact. Well, with minor performance and a very brief blackout window, which is what we call that pause period, that it's actually paused doing that last transition. And that's for most applications, like that pause is completely invisible. There is very little performance degradation for the majority of our virtual machines. And so most customers just don't even, their workloads don't even notice that we've done this. And it's very, very powerful compared to the alternative, which is essentially scheduling reboots and, we need to roll out a security patch for the latest Heartbleed, vulnerability or whatever. And so that required, our competition to reboot a significant chunk of their customers' VMs. And so there was this huge flurry of activity if you were a customer there where you had to go basically figure out when the best time you were going to be able to reboot in the next few days, because the machines that were running on that your VMs were running on were vulnerable. And then Google did the same thing. We patched all of our host machines, but we did it all using live migration, so we didn't have to require any reboots.
Excellent. Well, that sounds like super interesting stuff. I have to ask this, though, but feel free to dodge the answer. I totally understand. What sort of new features could we possibly be seeing for Compute Engine? I know we had Next recently, and we had a bunch of announcements there, but can you hint at anything? Can you touch on anything? I wouldn't be doing my job if I didn't ask.
Yeah, sure. I can talk in general terms. As you mentioned, GCP, the most recent GCP Next that we had down in San Francisco, we did talk about the fact that we're going to be adding more regions and zones over the next few years. And so, we are very serious about continuing to expand our footprint across into more regions that our customers are asking for, and that provide the locality that different workloads require. And so the first two of those areas that we're expanding to is going to be Oregon and Japan later this year. And then, obviously in 2017, we're going to be expanding into even more areas, more regions. So we'll be opening up new regions and zones. And that's going to be a huge that's going to be a huge benefit to customers, so that they can run their workloads where it makes the most sense and is near where their users happen to be. So that's one of the big things that we're doing over the next couple of years. And without getting too specific, we are also working on features that make it easier to troubleshoot your VMs, kind of like that hot grow PD thing that we talked about. If something goes wrong with the VM when it's booting up, it's often very challenging to figure out what went wrong. And so we're working on tools to make that a lot easier. Again, think the hot grow analogy where I just click a few buttons or call an API and it's solved. This is somewhat similar. You try to make it as simple as possible to figure out what went wrong and fix it without having to do the whole dance of, deleting the VM without deleting the disk, attaching the disk to another VM, figuring out what's the problem. And, basically there's this whole sequence. It's a real pain right now. And we want to make that easier. And then also, another thing we're working on are kind of more enterprise friendly pricing and usage models. Enterprises have quite a huge spectrum of requirements when it comes to how they do budgeting and how they figure out what they're going to spend their budgets on and that sort of thing. And so more enterprise-friendly pricing models are definitely something that we're working on to be able to make it easier for more enterprises to easily shift stuff over to cloud platform. And then obviously we continue, doing turning the crank on the bigger, faster, cheaper, computing. So those are in general terms. And if you're, anybody out there who's evaluating GCE or GCP in general, and you want to hear more about some specific details, please reach out to me on Twitter, and we can have a much more low level chat and much more detailed chat under NDA. So.
Cool. Well, I think we're pretty much running out of time, but is there anything else that you would like to mention? Some topics that we might have missed?
I think the biggest thing that I want to make sure if I could send everyone away with one to do or one action, I would say check out cloud.google.com. If you haven't yet, if this is the first time you're hearing that Google has a cloud platform, hopefully not, because, you've got some regular podcast subscribers and so people are familiar with it, but tell your friends, check out our website. There's a ton of amazing products that we have, data and analytics, machine learning, your basic GCE, your app engine, which is just write your code and deploy it and forget about it, and pretty much everything in between. And it's a very comprehensive platform, and we're really, really pleased to see the growth that we're seeing, but we would love it if we would always love more customers, and so please check it out.
All right. Well, thank you very much for joining us, Scott. It was an absolute pleasure to talk to you.
Yeah, it was great talking with you guys too. Thanks for having me again.
Thank you. Thanks again to Scott Van Woudenberg for such an interesting conversation.
Yeah, I really enjoyed it. It's good to see, people still talking about the basic building blocks of the cloud.
Yeah, virtual machines are a real thing,
Yeah.
even though they're called virtual. So yeah, very interesting. Let us know if you have any questions. We have the contact information for Scott on the show notes. And apparently he's very keen on getting your questions and opinions.
Yeah, and we're always looking for more questions of the week too. So,
Absolutely.
Yeah.
Yes. And talk about questions of the week. Let's go with the question of the week that for this episode comes from Noam Franco. And he says, "Hi, Francesc and Mark. It's a great podcast you have."
Thank you.
Thank you very much. And basically he says he listened to the episode on Humble Bundle. And we mentioned, Andy Oxwell mentioned that they were backing up data store to BigQuery via Google Cloud Storage. And he's basically asking, what is this magic? How does this work?
Right. So I had a look into this. It's actually kind of interesting. There have been ways to back up data store for a long time. A lot of them have been fairly manual. So we've got some links to the show notes. There is a way you can go in and enable the data store admin, and then go from there to back up all of your data store data in one big go. There's no incremental backup, but you can take the whole thing and say, okay, I want these particular kinds within data store, and then just put those in a storage bucket. And from there, once you've got that, it's relatively trivial to be able to point at that data store backup inside cloud storage and say, hey, BigQuery, can you ingest this, please? One of the cool things to note is that you can do scheduled backups. They are full backups though, so keep that in mind with your quotas and how much you want to be reading and writing from your data store. So you can do it with a cron from specifying a cron file on App Engine. You can totally do that. It's a little bit of custom code, but you can get that up and running depending on how often you want to be doing these full backups of this data. But then you can take those backups, you can ingest those into BigQuery either through the admin or through the API, and then you can access that data from BigQuery and do your analytics and all that sort of fun stuff.
Yeah, nothing really fancy, really. Just a bunch of things that you need to plug one to each other, and then everything just works.
Everything should just work. So, the admin will create jobs for you and run through task queues and do all this sort of stuff in the background. It's worth noting, like I said, it's not incremental, it's full backups. So if, for example, you're getting multiple kinds, they could be out of sync a little bit. So, it's not going to take a complete snapshot. So you sort of have to take that into account. But for stuff you're porting to BigQuery, I'm thinking that's probably less important.
Yeah, I guess that if you really wanted something that could do it weekly or daily or something like that, you could always build your own thing that could generate that. It could just create just a query of all the data that was created during the last day or so. But you're going to have to do more manual things. If everything you want to do is the whole thing and just dump the whole thing onto BigQuery, sounds like a good idea.
In some cases, this also could push towards a good argument for using things like PubSub.
Yes.
So that, when you go to store your data, it goes to your data, but another subscriber maybe picks that data up, shoves it off into BigQuery as well, and then you can keep that data alive in there and have multiple things do stuff based on those actions. And PubSub's a really great fit for that.
Yeah, absolutely. Cool. So before we finish, why don't we discuss, why don't we talk about our next plans? What are you going to be doing?
What am I going to be doing? So this week, we still have Change the Game here in San Francisco. Very excited for that.
What day is that?
That is a game conference we're running here in San Francisco. We're going to have a bunch of customers come by, some Googlers. I am co-presenting twice, so I guess that means I'm doing one presentation. So talking about multiplayer games, analytics for games, all sorts of cool stuff. It's going to be a really fun event. I know there's going to be a bunch of Googlers around as well. I will be there. Which I'm sure just makes it extra special.
I really like that my question was actually, what day is that? But you didn't understand me.
What day is that? I'm sorry. I thought you said what's going on there.
No. What day? What day? Oh, what day? What die?
Okay,
what die is
that? That is on Friday. So it'll
cool.
be a
June
couple
3rd.
of days. Yes, a couple of days after the podcast comes out.
Cool.
Yeah, after that, I will be presenting at GDG Twin Cities for their meetup. I will be at Open Source North. I will be at Dev Objective, and then I'll be in New York for a gaming panel towards the end of the month. I haven't got all the details of that yet.
Wow.
Yeah, I'm doing some travel this month. It's been
Busy month.
crazy.
Yeah.
Yeah, and then I'm taking a little break and spending a weekend in New York because
Nice.
why not? I know you're preparing for your long biking ride.
Yes, I'm going to be biking from San Francisco to Los Angeles, and I'm leaving on Sunday. So next week, I'm going to spend my whole week on a bike. Very excited. Very excited, slightly scared, but I think it's going to be fun.
Based on your level of sunburn, it looks like you're well prepared.
Yeah, that was from yesterday. Yeah. Yeah, and after that, I'm going to be taking a couple of weeks of relaxing and writing stuff and trying to be more productive without traveling. And after that, I will go to GopherCon.
Excellent.
Yeah, but that's in July. So we have a couple of weeks of recording podcasts before that.
Absolutely.
Well, thank you so much for joining me today.
Yeah, thank you so much for joining me as well, Francesc.
And talk to you next week.
I'll speak to you next week.